we're going to get started on the 6-1 notes, which are polygons and the polygon angle sum theorems. You'll probably notice that the notes look a little bit different. This is going to be so that all the geometry classes are using the same set of notes, so hopefully this will help you out a little bit more. I think these notes are organized in a very good fashion. We have the objectives to start off. We'll be able to identify and use polygons, find the perimeters of polygons, find the sum of interior angles of a convex polygon, and be able to find the sum of the exterior angles of a convex polygon. So first off, we're going to start off with the definition of a polygon. A polygon is a closed figure whose sides are all segments which intersect only at the endpoints. So a couple examples of polygons. A triangle is a polygon. It's a closed figure, so that means it begins and ends at some place. An example of something that's not a closed figure is this line. That line, this point's not connected to anything else on the one side. So that would be an example of something that's not closed or open. Another example of a polygon would be a square or a quadrilateral, or a pentagon. There are a lot of different examples here. Another example of something that's not a polygon would be like a circle, because it's not consisting of straight lines. The segments which intersect only at the endpoints, it doesn't fit that part of the definition. Whenever we are naming a polygon, we use the names of the vertices in order around the polygon. So remember, a vertex is like a corner point or where an angle is formed. Vertices is the plural vertex. So we could either name this polygon A, B, C, D. That's if we go clockwise, or A, D, C, B if we go counterclockwise. The same goes with this other polygon, which is a hexagon. We're going to get into the naming of the polygons here in a second. A convex polygon is a polygon for which there is no line that contains both a side of the polygon and a point in the interior of the polygon. So this says that the figure is convex. No sides are extended. None go in the interior of the figure. So how I remember convex is whenever you connect the corners, they always go inside the polygon. They never go outside. To give you a better idea, let's look at a concave polygon. So before we define it, I can have these two corners, and you see how they connect outside. You could think of like what a cave looks like, or the letter C. If I connect the letter C, it's like I'm outside of its shape. So a figure that is not convex is concave. So let's get down to the naming of the polygons. Hopefully these will all be familiar to you. We should know by now that a three-sided polygon is called a triangle. A four-sided polygon is called a quadrilateral. Five-sided is pentagon. Six-sided is hexagon. So hopefully those ones are familiar to you. Seven sides might not be as familiar. It's called a heptagon. 8 is octagon. 9 is called a nonagon. A decagon is a 10-sided figure. We usually call an 11-sided figure an 11gon. A 12-sided figure we could call a 12gon, but it's also known as a dodecahedron. And 12-sided, or sorry, n-sided is n-gon. So if we have like 16, we wouldn't have some special name for it. We would just call it a 16gon. Just like 11 is done with 11gon. The thing that might be confusing you a little bit is the 4-sided. A lot of you might be saying, well, isn't that a square, a rectangle, a rhombus, a parallelogram? Those are all special types of quadrilaterals. So we're going to be talking about those later on in the unit. Something else that's very important is a regular polygon. A regular polygon is a convex polygon. So remember, that means all the corners, whenever they're connected, go through the shape itself, in which all the sides are congruent. So remember, that word congruent is very similar to equal, and all the angles are congruent. So we're going to have to think back to what we've been doing for most of the year. We're told that square ABCD is regular. Any square is a regular quadrilateral. That means all the sides are congruent. So remember, we make these tick marks to show that the sides are congruent, and all the angles are congruent. So even if we don't know they're all 90 degrees, which we should, we can make those angle marks there. So we're asked to name each polygon by the number of sides and classify it as convex or concave and regular or irregular. So we count the sides. We have 1, 2, 3, 4. So this is a quadrilateral. It is convex. So remember, that means I can connect all the sides that don't touch, and it always goes in between or in the middle of the polygon. And is it regular or irregular? It's pretty clear that the sides aren't equal and and the angles aren't equal, so that means it's irregular. So let's take a look at number 2. It has 1, 2, 3, 4, 5, 6 sides, so that means it's a hexagon. Remember, a hexagon has 6 sides. It is concave. So see how these 2 points meet outside? That means it's concave. And it is also irregular. Remember, it's only regular if all the sides and all the angles are congruent. And since it's concave, that alone means that it's irregular. So a couple questions that'll keep coming up on your quiz and on your test. Big deal on the SOL is the interior angle sum theorem. This is something that they would also throw on the SAT. If a convex polygon has n sides and S is the sum of the measures of its interior angles. So we're going to have S, that's the sum of the measures of the interior angles, is equal to 180 times n minus 2. So there's a very easy way to show this. If I take a quadrilateral, I can make 2 triangles. And remember, the sum of these angles for the triangle is 180. That's one of the big ideas we should remember. So if I have a pentagon, whenever I connect all of these, again, I have 180, 180, 180. So whenever I add them up, that would be 5 minus 2 times 180. So that should give you an idea of where this comes from. It's how many triangles we can form on a polygon whenever we connect the one side. But we're just going to use the formula. So for a decagon, that means n is equal to 10. We have 180 times 10 minus 2. I can get the calculator out. and I just plug it in exactly as I have it written there. 180 times 10 minus 2. And I get 1440 degrees. For a 22 gon, that means n is going to be equal to 22. Remember, n is just the number of sides. So we have 180 times 22 minus 2. Again, I just plug it in the calculator. And 3600 degrees is going to be the answer. Number 2, we're asked to find the value of x. So we need to count how many sides there are. There are 1, 2, 3, 4, 5, 6, 7. So s is going to be equal to 7 minus 2 times 180. That's 900. So there are 900 total degrees here. So what needs to happen is I need to add up all of these angles and set them equal to 900. The easy way to do this, to solve my problem, would be to just take 900 and subtract every other angle that I have. So I'm going to subtract the 6 angles that I have from 900, and I'll see that x is equal to 117 degrees. For number 3, it's a little trickier because I can't do that same shorthand, but it's not too bad either. I see that I have a pentagon, so that means s is going to be equal to 5 minus 2 times 180. So I see that's 540 degrees. So I know whenever I add all of these up, they're going to be equal to 540. So let's combine like terms. Let's take a look at the x's. So I have 7x, 8x, 4x, 10x, and 6x. It's going to be 7 plus 8 plus 4 plus 10 plus 6. Those are my x values. So I'm going to have 35x. So I'm going to and then I'm going to take my numbers, plus 4, plus 3, plus 8, minus 4, plus 4. So 4 plus 4. So I get plus 15. So all I did was combine like terms, and I know that's going to be equal to 540. Once I have this, it should be a pretty simple algebra problem. So x is going to be equal to 15. I always want to check, did I solve it? No, I didn't. I need to find the measure of each angle. So I'm not going to complete this for you. I want you to complete this on your own. I'm only going to find one angle for you. I'm going to find this one here. So all I would do is 7 times 15 plus 4. I'm just substituting x. So I see that that's 109. So this top angle here is equal to 109 degrees. I want you to solve these other four angles just by plugging in the number 15. The last part on this page, we still have one more page to go, talks about regular polygon interior angles. The measure of each interior angle of a regular n-gon, so that means n amount of sides, any amount of sides, is n minus 2 times 180 divided by n. So it's the same formula as above, but all I do is divide it by the number of sides in the end. So our example asks us to find the measure of each interior angle of a regular nonagon. So remember, nonagon, n is equal to 9. So I'm just going to use this same formula that I have. 9 minus 2 times 180 over 9. So to make sure I'm using the order of operations right, I'm going to use two parentheses. So 9 minus 2 times 180, that's my numerator. So you see how my parentheses are closed, and then I'm going to divide it by 9, the denominator, and I see that each angle is equal to 140 degrees. So I'm going to say 140 degrees is the measure of, let's extend the page, each angle in a regular nonagon. So the last page talks about the exterior angle sum theorem. It says if a polygon is convex, then the sum of the measures of exterior angles, one at each vertex, is 360 degrees. The way that I remember this is that you can have a circle. A circle is 360 degrees around. We're going to talk about that more later, but you should know that already. We see that angle A is this big here. Angle B is this big. Angle C. Angle D. And angle E. So whenever I add all those angles up, it's going to be 360. It doesn't matter how many sides I have because I can always form that circle around it. So we're given an example. We're told a convex hexagon has exterior angles 48, 52, 55, 62, and 68. What is the measure of the sixth exterior angle? So that means we would add them all up, and they would we'd add up all the angles, and they would equal 360. We're given 5 angles. So x is going to be equal to 360 minus 48 minus 52 minus 55 minus 62 minus 68. You can use your calculator, and you'll see that that should be 75 degrees. That would be the measure of the sixth exterior angle. So just like before, now we're going to move on to regular polygon exterior angle. Just like before, where we had n minus 2 times 180 equaling the sum of of the total angles of a convex polygon, we know that any convex polygon has exterior angles adding up to 360. So we're just going to divide it by n, just like we did before, the number of sides. So the measure of each exterior angle of a regular n-gon is 360 divided by n. So we're just going to use the formula. This problem says Find the measure of each exterior angle of a regular nonagon. So that means n is equal to 9. So we have 360 divided by 9, which is 40 degrees. And we have one more thing that you need to know. An interior angle and its adjacent exterior angle of a convex polygon. So this doesn't even matter if it's regular or not. We're given a picture here. Are supplementary. So remember, that means they add up to 180, and they're also called a linear pair. So whenever we have an interior angle and an exterior angle, it shouldn't be external, it should be exterior. They'll add up to 180, and they're a linear pair. I hope this helps. Whenever we come to class, we're going to work on some practice. Please come prepared with any questions. You have a few examples. If any of them didn't make sense, make sure you ask me in class. Have a great day.